In this video, we will develop a custom game viewport client that will manage all of the logic we will implement. Now we're ready to start implementing our global screen fade system. The first crucial component we'll create is a custom game viewport client class. The game viewport client is always alive and renders after everything else. That makes it the perfect place to draw full screen effects like fades. It also avoids widget stacking issues and works even during map transitions and even when the game is paused. Let's break this down into manageable steps. First, we'll open the starter project in Unreal Engine. Once it's loaded, we'll create a new C++ class with GameViewportClient as the parent class. In our GameViewportClient, we override init so we can hook into map load events, and post-render so we can draw our fade quad. Then we expose a fade function to Blueprint and a native completion delegate for sequencing. Next, we'll configure our project to use this viewport client. Let's look at how we'll create this for our project. All right, so now that we have our starter project open up here and running, let's go ahead and let's create a custom game viewport client. So let's create a new C++ class and let's search for game viewport client. So this will be the parent class that we have of our custom game viewport client. So let's just call that custom. All right, so now that that is opened up in Visual Studio, let's go ahead and add some functionality to this. So first, we'll start off with our private members. So we're going to have a Boolean to indicate if we're fading or not. We're going to have a couple of floats to store the current alpha, the start alpha, and the target alpha that we want to get to. We're going to keep track of the start time of the fade in real time so that we can progress while we pause. We're gonna be able to control how long we want the fade to be. So for now, we can just have it half a second, and then this tracks to see if the direction that the fade is requesting in. Then let's have our a private function. So this one is the draw screen fade. So this will draw a full screen black quad with the current alpha value that we have. And then finally, let's have all of our public functions. So here we're going to override the init function. We're going to override the post render function. We're going to have this fade function that we'll be able to call from blueprints, and then we can pass in a Boolean to it if we want to fade from visible to black or from black to visible. We're going to have a delegate. Let's find the definition for that. So the delegate will be used to let us know when the fade has finished. And this is just a multicast delegate that's C++ friendly that we can bind our lambdas to it. And then we finally have this end fade function. This function will be called as soon as the map has finished loading to start our fade from black to off. So let's take a look at the C++ implementation now. So the first function that we're going to take a look at is the init function. For this one, we call the parent init. Make sure that the world is valid. And then all we do is we bind to the post load map with world delegate. This gets called after a map has been loaded. And we wanted to call our end fade function. For our post render function, we're going to call our parent post render. If the canvas is not valid, we just early out. And then we check to see if we are fading or if the current alpha is greater than a very small number or greater than 0. Then we want to draw the screen, the fade. Next function that we have is our fade function. So this is going to, again, take to see if we want to fade to black or not. Make sure we have the world is valid. We're going to get the current time at the moment. If we are fading, we want to, so this is if we're halfway through a fade and we do another screen transition, we want to compute the current alpha so that we can continue nice and smooth. So if we are currently fading, we see how much time has elapsed from now until the last time we did this. Then we clamp that to 0 and 1, just to make sure that we don't overshoot any of it. And then we lerp from the original start alpha to the target alpha based on how far along we've come. If we weren't fading, or if we were, we just set this to true. And then we requested to black will be the Boolean that was passed in. The start alpha will be the current alpha. So typically it'll be 0 or 1, or if we are mid fade, it'll be whatever we calculated over here. Then we set the target alpha either to 1 or 0 based on if we want to go to black or not. And then we update the fade start real time to the current time right now. If the start alpha and target alpha is nearly equal to 0, it means that the fading has completed. So we set fading to false. We set the current alpha to the target alpha, and then we broadcast our on fade finished native delegate by passing in requested to black. The next function that we have is our end fade function. So this is the one that gets bound to the post load map with world, and it needs to have taken the newly loaded in world. And for that one, we're just gonna call fade by passing in false so that we can go get away from the black screen fade. And then the final function that we have is to actually draw the fade. So to draw the fade, we get the current time. We check to see if we're fading. We try and figure out how long we are in the fade, and then lerp the alpha accordingly. So again, we clamp from 0 to 1. We calculate the current alpha based on the start alpha and the target alpha and the value that we calculated up here. If we've reached or passed the target alpha, so if that is greater or equal to 1, then we clamp to the target to ensure we end exactly at the target value. So we set the current alpha to the target alpha, and we specify that we're not fading anymore. And again, we broadcast our on finished native delegate. If the alpha is 0, we don't need to do any drawing at this point, so we just early out. Otherwise, we store the old color of the canvas so that we can restore it after we're done with this. We set our fade color to black, set our alpha to the current alpha that we're in. We set the canvas's draw color to this fade color. And then we get the default texture of the canvas, and that is the one that we're going to use and pass in the appropriate color for it that the canvas is set to. And then we call the canvas's draw tile function, pass in the texture, pass in the X and Y values, pass in the length and the width in X and Y. So we want the entire screen, so we use the entire canvas, and then pass in the U, V's, and the length of them as well. And then finally, at the end, we just restore the color. We do need to have an include for this canvas, and that include is inside engine canvas. All right, so let's build this, make sure that this thing builds. All right, and now that this has successfully built, we can open up our project again, and we can make sure that our project uses the custom game viewport client. Right, so to do that, we can open up the project settings, and we can search for a viewport here. And inside the default classes for the game viewport client, we can select this custom game viewport client. Once we do that, you will see a restart required to apply new settings message pop up. Make sure that we restart the project to have that fully take effect. And now that the project has restarted, it will be using our custom viewport that we created. In the next video, we will create a blueprint function library, which will be the clean interface the rest of the game uses.